In this video, we're going to look at percent change. So we're going to find in the last, we looked at increasing a value by a percentage. Now we're looking at how do we find the percentage that a number was increased or decreased by. So the percent that a quantity changes from the original amount. To reiterate, when the original amount increases, the percent of change is called a percent of increase. So stating if it's an increase is important. When the original amount decreases, the percentage of change is going to be a percent of decrease. Indicating if it's an increase or decrease is necessary. So we don't just want to report it as a percentage. We also want to indicate, did it go up by that percentage or did it go down by that percentage? So when is it used? It's used when we want to find that percent of increase or that percent of decrease. So if we're just reporting some type of statistic or value, often done in the news or in an article, or if we want to find the percent of discount. So when we think of discount, we think of shopping. So kind of finding out how much did you save as a percentage. Something's maybe $80 and it's marked down to $45. And just instead of saying I saved this amount, we would report it as a percentage. Or we can find the percent of markup. So on the reverse there, if something's increased by a percentage, for example, a store is marking up an item to sell it to make profit or a larger profit, we want to know kind of what that measure is as a percentage. How to find percent change. So we're going to focus on how to find that percentage. So what we're going to do to find the percent of change, we want to know how much the amount has changed by. We're going to refer that just as the change. So how much did it change by? How much did it go up by? Or how much did it go down by from the original to the new? And we're going to divide that by where it started, the original amount. So these are the two big pieces we have to find. So we want to know the change and divide that by the original amount. And that's going to give us our percentage. Then we would label that percentage as an increase or a decrease based on which direction it went. So let's look at example 1. When you buy a share of stock for company A, it was $6 a share. When you sold the stock, it was $8 a share. How much did it change as a percentage? So the first thing we want to do is identify, are we talking about an increase or are we talking about a decrease? So we went from $6 to $8. So we are talking about an increase here, an increase in the price of the stock. To find this percent change, we are going to find out the change and we're going to divide that by the original. To find the change, we're always going to subtract the smaller value from the larger value. We're not concerned with which is new and which is old at this case. We just want to find that amount that it's gone up by or down by as a positive value. So if I was going to find the change here, I would do 8 minus 6, and I would divide that by my original stock price, which in this problem was 6. So this is going to give me 2 divided by 6. 2 divided by 6 is 0.333 repeated. So remember, this is a decimal. We want it as a percentage. So move that decimal 2 spaces to the right. 33.3%. And we're going to indicate that as an increase. So this stock was $6 and increased by 33.3%. Example 2. The population of Prentice 5 years ago was 12,000 people. This year, the population is 9,950 people. What percent has the population changed? Again, let's start with, are we talking about an increase or are we talking about a decrease? We would be talking about a decrease because we went from 12,000 5 years ago to the new population of 9,950. So we did go down, which means 12,000 is our original, 9,950 is our new. So if we want to find the change divided by the original, our change, we're going to take our larger value, 12,000, and subtract 9,950. And our original value 5 years ago was 12,000. This gives us 2,050 divided by 12,000, which gives us a decimal approximately, I'm going to use an approximate symbol of 0.17, which we would say is a 17, I'm going to rewrite that, 17%, and we said it was a decrease. So the population of Prentiss, Wisconsin in 5 years went down 17%. Let's go ahead and do example 3. A new ottoman was $185. When you bought it, it was marked down to $110. What percent did you save? So if there was a percent off sticker sitting on this ottoman, we want to find out what that number would be. So change divided by original. It went from $185 to $110. So this is going to be a decrease, which is good. We're saving money. 185 minus 110 divided by the original, 185. That's going to give us 75 divided by 185 for an approximate decimal of 0.405, which would be 40.5%. And this we said was a decrease. So next we're going to look at a few more examples. So if you want to pause the video, you can go ahead and try these three problems. We're going to go through them right now. So what is the percent change? So again, we're looking for percent change from 10 inches to 25 inches. So remember, we want the change divided by the original. So the change from 10 to 25 is 15. We would find that by doing 25 minus 10. We divide it by the original. So the original number is 10 inches. The reason it's 10 inches is we're going from 10 to 25. So implying that 10 is the original. So we're going to say 15 divided by 10, which gives us 1.5. Moving that decimal 2 places, that's 150%, noting that it is a increase. In example 2, what is the percent change from 90 to 60? It's 90 ounces to 60 ounces. So we have a 30, goes down 30. So our change divided by our original. So we have 30 is the change divided by the original number, which in our case is 90. It's where we start. 30 divided by 90 equals 0.333 repeated, giving us a percentage of 33.3%. And in this case, 90 to 60 is a decrease. The bar graph shows this, or example 3, the bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? So if we look at our graph, here on the y-axis, we have seasons. So 2010, 2011, 2012, 2013. And on the x-axis, we have home runs. So we're looking at the 2012 and the 2013 season. So from 2012 to 2013, we have a change of 8 home runs divided by the original. So which number in this problem is the original? Well, we went from the 2012 season to the 2013. So 28 is our original going to 20. So we're going to put 28 in the original spot. This gives us a decimal of approximately 0.286. So we would say it's a 28.6%. 28 to 20 is going to be a decrease. The last aspect of percent changes is really percent error. So a percent error is the percent that an estimated quantity differs from the actual amount. So we're saying basically what percentage you're off by if you were making an estimation. So to find percent error, we're going to take the amount of error, so how much we were off by, and divide it by the actual amount because we want to compare to the actual thing. You estimate that the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. So percent error from our formula above is equal to the amount of error, which in our case, the amount of error, how off were we? We estimated 16. It actually was 21. So we have an error of 5 feet. Now, the actual amount, 21. So we're going to divide that by 21, giving us approximately 0.238. So we would say our percentage of error is 23.8% error. So that's like how off we were. Probably get my decimal in there again. So that is a review, or how to find percent change. So again, finding what the percentage it increased or decreased from the original amount.